Chapter 11, Lesson 6, Isometries and Coordinates. Okay, go ahead and pause here and take these notes. All right, so for the first one, we're talking about a reflection over the y-axis. So taking basically a point that might be in quadrant 1 and reflecting it over here to quadrant 2, or taking something in quadrant 3 and reflecting it over here to quadrant 4. So in that case, what we're doing is we're actually taking it from the positive side of the x to the negative side of the x. So the y coordinate's staying the same since it's on that line. And so what we're going to do is we're going to do the opposite sign on the x coordinate. Now, when we're taking a point and flipping it over the x-axis, so I'm taking a point here and moving it down here, the x value stays the same, but it's the y value that becomes a negative. The next one we're going to talk about is rotating a point 90 degrees about the origin. So what we're going to do is we're going to switch the coordinates and change the y coordinate to a negative. So basically I'm taking a point from here. This is not going to be a good 90 degrees, but that should be 90 degrees, and moving it down here. So if this was a comma b, whatever the numbers are, this is going to be negative b comma a. I went the wrong way. 90 degrees. Sorry, this way. There. Negative b comma a. I forget when we rotate it, we go counterclockwise, not clockwise. When we rotate it 180 degrees, we keep the original AB point, but now they're just both negative because they go down to quadrant 3. When we do 270 degrees, that's when it comes over here and becomes B comma negative A. And then for left or right translations or up or down translations, if we're going left or right, we want to add it to the X term. And if we're going up or down, we want to go and change that with our Y term. All right, so we're starting with the point 3 comma 4. And the first thing we're going to do is reflect it over the x-axis. So if I just look at a picture of 3 comma 4, and I'm reflecting it over the x, it's going to go down here. And again, that means that we change the y. So instead of being 3 positive 4, now it's 3 negative 4. If I want to take this point here and reflect it over the y-axis, it's going to change my x-coordinate. So it's going to be now negative 3, but still at positive 4 for the y. On this one, I'm going 5 units to the left, which is going to affect my x-coordinate, and 4 units down, which is going to affect my y-coordinate. So I started with the original 3 and 4, but then to the 3 I subtracted 5 to move it to the left, and then to the 4 I subtracted 4 to move it down. So my new coordinates for this one would be negative 2, 0. Okay, on the next one, I am going 3 units to the right, so that's going to affect my x-coordinate. And 3 units down will affect my y-coordinate. So that would give me 6 comma 1. Now for the 90 degrees, there's my original. For the 90 degrees, and again, it says we're going counterclockwise, which is to your left, opposite of what a clock would be. So I'm going to switch the coordinates, first of all, and then make the first one a negative. And then for the 180 degrees, all it said to do in my notes was to make them both opposite signs. Okay, on this one, we have 3 points that we are changing each time. So here are the originals, negative 2 comma 3, negative 1 comma 5, and 2 comma 0. So the first thing we're going to do is reflect over the x, which affects the y coordinates. So M is going to become -2, -3, N, -1, -5, and P, 2, comma, and since there's no such thing as -0, I'll just leave it as 0. The next thing, reflection over the y-axis, is now going to affect our x term. So again, I'm going from the original up here. So it's going to become +2, comma 3. N will become +1, comma 5. And P will become -2, comma 0. On the next one, we're going 2 units to the left, which will affect my x term. So my x term is going to get whatever it is minus 2. 3 units up will affect my y term. So I'm going to do whatever my y term is and add 3. So for M, I'm going to start with -2 minus 2, which is -4. And then 3 plus 3, 6. For N, I have -1 minus 2, which is -3. And 5 plus 3 is 8. And for P, I have 2 minus 2, which is 0. And 0 plus 3, which is 3. On number 4, it wants me to add 3 to my first term and subtract 1 from my second term. So for N, I'm going to add 3 to -2, which is 1, and subtract 1 from 3, which is 2. For my N, I'm going to add 3 to -1, which is 2, subtract 1 from 5, which is 4. And for the P, add 3 to 5 and subtract 1, -1.
Oh, sorry about that.
Okay. On this one, we're going to be changing the A to the opposite sign and then subtracting from the B. So on M, I started originally with a -2, and now I need to do the opposite of that according to this. So I'm going to change that to a +2. And then from the 3, I'm going to subtract 6, which is -3. On the N coordinate, it was a -1, so I need to do the opposite. So I'm going to change it to a +1. And from the 5, I'm subtracting 6, which is -1. On the P, I'm doing opposite on the X term, which is -2, subtracting 6 from 0, which is -6. Okay, on number 7, I am doing 3 units up, which is going to affect my Y term, and then flip it over the x-axis, which changes my x term to the opposite sign. So for the M, it was -2, so now it's going to become a +2, and 3 plus 3 is 6. The N, it was a -1, so I'm going to change it to a +1, and 5 plus 3 is 8. For the P, it was a +2, I'm going to change it to a -2, and 0 plus 3 is 3. On this one, 4 units right is going to affect my X term, and then over the x-axis will affect my Y term. So for the M, I have -2 plus 4 is +2, and it was a +3, so I'm going to change it to -3. For the N, -1 plus 4 is 3, and it was a +5, so I'm going to change it to a -5. And for the P, 2 plus 4 is 6, and I can't really change it to a -0, so I'm just going to leave it as 0. On number 9, we are rotating 90 degrees counterclockwise. So remember, I switch the order of the coordinates, and then I give the first one the opposite sign. So for M, we had -2, 3. So that is going to switch the position of the X and the Y and then change the sign on the first term. For N, it was -1, 5. So I'm going to switch their positions and then give the first one an opposite sign. And for the P, it was 2, 0. So I'm going to switch their positions. And I can't really give the 0 a negative, so it's just going to stay as 0, 2. For 270, I switch their positions, but change the second coordinate. So again, this one right here shows my original M. So I'm going to switch their positions and then change the second coordinate. So it's going to become a positive. In N, here's my original. So I'm going to switch their positions and change the second one. And for P, here's my original. So I'm going to switch their positions and change the second one. For 180 degrees, all I do is just change the signs on both of the terms. So again, here's my original M. So my new one, just change both signs, +2, -3. For N, change both signs, +1, -5. And for P, change both signs, -2. And again, I can't change on the 0, so I'm just going to leave it as 0. On number 12, they want me to rotate it 90, which I already did here in number 9. And then I'm also going to reflect it over the X, which is going to change the sign on my Y. So I'm actually going to go off of what I did on number 9, the answer here. And then all I'll have to do is change the Y. So it's going to become -3, +2. N will become -5, +1. And P will become 0, -2. Number 13 asks for a 180 rotation, which I've already done here in number 11, and then reflected over the Y, which is going to change my X term. So this one, M, will become -2, -3, N, -1, -5, and P, +2, 0.